All right, so again, I go through a handful of questions from last night's homework, and you should be able to get these right. Ivy, can you kill the lights, please? Okay, first one, quadratic equation. The big thing I want you realizing here is this is a good quadratic equation question where I had to simplify the radical 44. I had to make it 2 radical 11, and then I had to simplify. In other words, where I really want you paying attention is at the end here. Did you do that step correctly? That's the last thing there is to know about quadratic formulas or quadratic equations. Okay. If you notice that you're having an issue with any of these things, really bring it up and talk to me. We can do that at lunch. We can do it in the mornings. There was nobody here at Extra Help today. I mean, it makes my day easy, but I want to make sure that you know what you're doing. We have a test next Wednesday, I think, Thursday, something like that. And I want to make sure you're completely prepared. And the test items are going to be like the quizzes. They're going to be like what it is that I'm putting up on these homework questions. That's why they're there and being done. Okay, the recursive form, which is what we have here, is the best way to make the sequence. A sub 1 is the first term. It's 11 or 12. And then you add 5 every time. Does that say plus 5 or minus? Minus. Oh, well, I went in the wrong direction. It should go the other way, 12, 7, 2, etc. Sorry about that. Here is the formula. That's what I get for doing these things so quickly. So yours should go 12, 7, 2, negative 5, and so on. Okay? And then here's the beauty of the explicit formula. With the explicit formula, you just plug in the 6. You just plug in the 100. And naturally, I did this one on the bottom wrong here. That should be 99. Okay, so that should be minus 5 times 99 because it's always n minus 1 here. Okay, the radicals. Negative 5 radical 5, right? 25 is the biggest perfect square that goes into 125. 16 is the biggest one that goes into 32. And as we mentioned the other day, square root of 16 is 4, but don't forget the 10 in front means multiply. 10 times 4 is 40. And with the cube roots, the biggest cube root that goes into 16 is 8. So I get plus or minus 2 cube root of 2. Okay. Arithmetic and geometric. And each in recursive form. Recursive form, you always list the first number, and then you list what's happening. In this case, I'm adding 2. In this case, I am multiplying by 2. And in this case, I am adding 3. Okay. I guess this says to write out the first 5 terms or whatever. 11's the first term, and then you go up by 6. And then it says, using the parent function, y equals absolute x, the roll of each number. 2 makes it twice as narrow. The 7 moves it 7 to the left. Remember, it's always opposite in the packages. And the minus 1 is 1 down. Okay? Any questions? All right. So again, it's just very, very important that you get your work done and then you check it over to see if you're doing things right. For instance, I just screwed up those 2 questions just because I went quick. So we want to make sure that you know what it is that you're doing, and when you make a mistake, be aware of it. All right, is today's number 29, I think? 28, okay. Okay, this one says do number 2 only, list the first 5 terms, and then do all 3. So, without any further ado, let's get rocking. This is, we're pretty much done with lessons dedicated to sequences. We'll practice them every day on homework and on quizzes, but we're done with lessons. Okay, this says the new term is the old term plus 2. This says the first term's 50. So the next one's 52, 54, 56, 58. There's my first 5 terms. Okay, for problems 5 through 10, I'm going to do all 3 of these. Write a recursive formula.
It's a division sign. It's not plus 2.
Is it a division sign?
Yeah.
Okay, sorry. 25, 12.5, 6.25, 3.125, etc. Okay? So this would then be a geometric sequence. Now, a plus 1 pattern. A sub 1 equals 8. The new term is the old term plus 1. Follows a times 10 pattern. A sub 1 is 4. A sub n plus 1, in other words, the new term is 10 times the old term. And then here, write an explicit, oh, that is the explicit formula. Okay, so if I put a 1 in there, I'm going to get negative 3 times 1 is negative 3, plus 2 is negative 1. So my first term is negative 1. And then for each succeeding term, I'm going to go down 3. That's what the negative 3n in front will do. That's the rate of change. So I'll change it up a little bit here, right? A sub n equals a sub n minus 1. Again, new term, previous term. Doesn't matter if you use an n plus 1 and an n, or an n and an n minus 1. It's the same thing, minus 3. Okay? Questions? All right. You know, with the sequences stuff, I just think it's a little weird. I don't think it's that hard. And as my old high school teacher, Mr. Braze, used to say, oh, you gotta lock yourself in a closet, think about this stuff. And once you do that, and it all starts coming together, you go, oh, that's it, it's not so bad. So, work hard. There tends to be a feeling sometimes that you should leave the classroom with material mastered. Bless you. And the younger you are, the more true that is. The harder material you're taking, the less true it is. It was very frequent in college where you would get a lesson, and all the lesson would serve to do is make you go home and think. And you would spend hours and hours and hours thinking about what it was that you had in class. And then you would come back in and think about it some more. You're kind of in between here. Perhaps for the first time in your life, you're encountering material where you don't just look at it and get it. You don't need necessarily, when you're in 5th grade, you don't necessarily need to do 25 decimal problems a night to understand that when you add decimals, subtract them, you line them up. When you multiply, you count the total places and just move it over. But this is a whole lot more complicated than that. And sometimes part of the learning is that you need to go home and you need to rely on yourself. Not on me, not on anybody else, but yourself. I get you started, I put things in the right direction, you go home, you work hard on your own. When you don't get it still, if you don't get it still, you probably will, but if you don't, then you come into extra help. And like I said, it was empty today, and last night at the library, I think I had maybe 2 kids. So, 2 of my kids. So I really think we need to work just a little bit harder on this. Make sure we get it down pat. Okay, today we explore 2 types of interest formulas, simple and compound. Now, you already did simple interest in the past, and it's really not the emphasis of this course to talk about simple interest, okay? But I do want to cover it just in case. Simple interest is the formula I equals PRT. Do you remember that from like either 6th or 7th grade? No? All right. Simple interest is not the way the real world works. If you borrow money from someone like the mafia and a loan shark, they do simple interest. Simple interest is really simple. Very good. All you need to do is multiply the P, which is the principal, it's the starting amount, R is the rate of interest, you always got to write it as a decimal, and T is the time. And then compound interest, this is the real world, okay? And we'll do some examples with that in just a couple of minutes. Don't go too nuts with it, okay? You will get that formula, by the way, and at least for now. And then in a couple of days, it'll be easy. Kira's been babysitting since 6th grade. She saved $1,000, wants to open an account at the bank so that she will earn interest on her savings. Simple Bank pays simple interest at a rate of 10%. How much money will Kira have after 1 year, 2 years, etc.? Okay, so here's the formula. The interest is the principal times the rate times the time. So she takes $1,000. Oh, wrong spot. Takes $1,000, puts it in the bank. What's her interest rate? 10%. By the way, I want you to understand that that is not reality. Right now, interest rates are about 1%. Okay? So I have to express the interest rate as a decimal, which is 0.10. Now, if she's going to, how much money will she have after 1 year? So the time is 1. Now, 1,000 times 0.10 times 1 is $100. But that's not how much money she has in the bank. she has 1,100. She has the 100 she earned in interest plus the $1,000 she started with. So she has 1,100 in the bank. Okay, so that's a very basic example of how we compute simple interest. Now let's try the next one. For year 2, how much money does she start with? Hint, it's not 1,000. 1,100, good. The interest rate stays the same, it's 0.10. This time I leave it in for another year. What is 1,100 times 0.1 times 1? 110, good. Then I take that 110 and I add it to the 1,100 that was in there at the start of the year, and I get $1,210. So that's how much she would have in there after 2 years. Now, after 5 years. Oh, it says after 2 years she doesn't add any money to the account one way or another. So that means she's going to start with 1210. What's the interest rate again? 0.1, 10%, which is 0.10. And now she's going to leave it in there from the 2nd to the 5th year. How many years is that? 3. So do 1210 times 0.1 times 3. 363, and then I take that 363 and I add it to the 1210, and I come up with 1573, and that's how much money she would have in the account. Okay, so those are 3 examples of simple interest. If you don't remember, now that I did it, is there anybody here who does remember doing it? Okay, back in the day, I used to teach 7th grade math a little bit. This was a 7th grade math topic. Can everybody see this as phenomenally simple?
Yes.
Okay. So, but that's not the way the real world works. This is the way the real world works. Raul needs $200 to start a snow cone stand for this hot summer. He borrows the money from a bank that, oh, this is simple interest. This is still not real. How much will he owe if he waits a year to pay back the loan? 2 years, 3 years, 4 years. Let's just do 4 years. I don't want to do them all. All right, I don't have all day for this. Figure out what's the interest. It wants to know how much does he have to get back to the bank if he takes the loan for 4 years. So only do the option for 4 years. Go ahead. What is the interest? I equals PRT, also known as I equals PERT. I think you come up with 32 bucks? Is that what he owes the bank? No. What does he owe the bank? 232 bucks, right? Because you don't only pay interest, you also pay back what they call the principal, the amount that you started with. Okay? I mean, think about it for a minute. If someone comes up to you and says, listen, I need to borrow milk money. Can I borrow a quarter? And then you say, okay, but you're going to charge interest. And let's say the interest works out to 5 cents. If they come back the next day and they give you 5 cents, have they given you all the money they owe you? No. Don't forget about the cost of the milk. They're supposed to give you 30 cents. Okay. Now, what's that? All right.
What kind of milk costs 25 cents?
All right. Hold on. I'm not worried about the milk. Now we're getting into a little bit of real life. Okay? Jack. Jack is now
In real life.
investing money. Yes, Jack in real life. Jack is investing money. He invests 500 smackaroonies. He invests it at an interest rate of 6%, and here's the key phrase. Talk about magic word. Compounded annually. Now, here's how your interest formula works. Ready? First thing that's different about compounded interest versus simple interest, this is extremely important. Listen up. the value you get, A, is the amount that's in the account. It's not just the interest, okay? So it's the amount that is in the account is going to equal the principal. Then it's gonna be 1 plus or minus the interest rate to the t for time. Now, what do you think the difference is between, why a plus or minus symbol there? We're dealing with interest now, right? Or whatever it is that's going on. If you have like a bank account that you're depositing money and that money is increasing, what sign do you think you would use? Plus. But let's say you do something else, like you buy a car and you have a loan, and the formula is used to figure out the value of the car. Well, do you think your car is worth more a year after you buy it, or less? Less. So you wouldn't use the plus sign, what would you use? The minus. So this formula works for when things are increasing in value. It also works for when they are decreasing in value. The plus is used obviously for increasing, the minus is used for decreasing. So if I want to figure out the amount in the account, it is, what did I start with? 500. Now, I always begin with 1. The reason I begin with 1 is 100%. Everybody say that, 1 is 100%. So when you're adding 6%, you actually want to come up with 106%. So you start with the 1, and then if you're going to go down, like if it loses 5%, you want to go down 5, you're going to get 0.95 or 95%. So it's 1. Now this is an interest rate at a bank, so it's going in a loan, you're investing it. Is it going up or down? Up. Plus, now 6% as a decimal is what? 0.06. To what power? Now, let's do 2 years to the second power. Now, what I want you to do is to put this into your calculator. You can either, hold on, slow 1 second. You can either do the 1.06, 1 plus 0.06 in your head, or you can literally use the parentheses and just type what you see. Either way, you will get the correct value. All right, what do we got? Note to self, do not shoot peanuts and peanut M&Ms while kids are answering because you will not hear. Hold on, go again. 561.80. So that's the total amount in the account. How much interest was earned? 61.80, right? Okay. Now, let's do 5 years. Oh, 10 years. Do 10 years.
Oh, great,
Okay, what do we get? Bless you.
895.43 cents. That's what I got.
Everybody agree? Everybody agree? Okay. So that is how you figure out interest. The big thing you need to remember, P is the principal, what you start with. This is the one you're going to see. You probably won't see simple interest. 1 plus or minus the interest rate to t for time. Now I want to talk to you about how to get rich. Who wants to know how to get rich? Raise your hand if you want to be rich. I have never wanted to be rich.
Hey, bro.
Never been important to me until recently. And I haven't wanted to be rich because I want to be rich. I wanted to be rich because I wanted to use the money to help people. I would love to own a company. Whatever I make, I don't care. And I just want to employ people that I value, people that I really think are special. And if I could do that, then by having money, I could help people have better lives. Now, how much money do you have to have in the bank for you guys to think you're rich? Give me a guess.
$10.
I remember being your age and thinking $10 was a lot of money. Nowadays, you get your sandwich at the deli. Yeah. A billion. Well, obviously a billion's there. The lowest amount of money you think you could have to be rich? $1 million. $1 million? 50 million? Well, you ain't high. Okay. All right. I want to tell you a story about when I first started teaching. I was on the job for maybe 3 or 4 years, if even less, probably more like 2 years. And I had one of the people in the teachers union come and visit me, and they said, we need to have a conversation. I said, okay. They said, you need to start putting money in the bank. And I was like, I can't even make my bills. How can I have money in the bank? He said, do what I said. He said, put the money in the bank. He said, we're going to set up, it's not just a regular bank. We're going to set up a type of account called a 403B. It's like a 401k. But a 403B is much more powerful than a 401k. Only public employees can get 403Bs. He said, I want you to put $15 every paycheck in, which amounted to $30 a month, which really isn't a lot of money. He said, learn to live without it. He said, every time you get a pay raise, and when you're a young teacher, every year you get a small raise every single year. He says, I want you to take some of the raise and put it in the account. And then I want you to just leave it there. Don't touch it. Now, I started with $15 a check. I'm now up to $300 a check. I never got used to living on that extra money because I never had it coming in. I now have $200,000 in a bank account, cash, because of this formula. Okay? Let me show you how this works. I have a fund called the American Fund. The American Fund has averaged 13.5% interest for 80-something years. That's the average rate of interest. Okay? Now, right now, today, I have, it's actually not 200,000, it's like $192,000 in the account. Now, let's say that I decide not to touch it for the next 10 years. Right? How much money's in the account? I am gonna touch it, but let's just say that, I decide not to touch it. I got places to go fishing. What was right?
I think this, doesn't that mean like
Did you get that for your formula?
No.
All right.
Well, yeah, technically, yeah. Yeah.
Okay.
Oh, shoot, I did it wrong.
I don't think I did it.
What does that work out to?
681,000.
Wait, what?
How much?
Like 7.888.
How do you turn 13.5
Hold it. I have a question. Question is, how do I turn to 13.5? Look, when you convert a percent to a decimal, you move 2 to the left. So watch, ready?
Oh, that's what it, okay.
1, 2. And then it's always 1 plus 0.135. It's always 1 plus or 1 minus. No, I did it in my head.
Great,
So,
okay.
all right. That's me. That means if I don't touch it for 10 years, I got $681,000 in the bank.
You should do that.
I wouldn't touch it. Let's talk about you. Let's say you get the same American
All the
Fund
money I have.
that
in
averaged
my bank.
13.5% per year. Now, let's talk about from now until you graduate high school. Anybody here intend to make some money?
Maybe.
Maybe. Okay.
Like, when you say.
Do you think it's possible to put $2,500 away between now and the end of high school?
Yes.
Yes.
I think that's very possible. really do. It will if you have a little discipline, and this might motivate you to do it. So you're gonna take $2,500. Now, people tend to retire at about age 65. You graduate high school at 18. So that means you're gonna leave it in there for 47 years. $2,500. Let's see what it turns into. Go ahead.
Wait, oh.
Figure out what it's worth. This might just motivate you to make $2,500.
How many years?
Back.
Wait, what? Oh.
961,000. 961,048. Point what? Don't want to lose that 93 cents. Now, why? How did it get so big? How did it turn from 2,500 to just about $1 million? Yes, and the reason is because this particular function, if we look at it here, ready? A equals P times 1 point whatever to the x or t is a exponential function. What does the graph of an exponential function look like? Little money, little money, little money. You get to a certain point in time and that money is growing so fast that you become super rich. Do you ever read about the people in the gossip pages? People like Paris Hilton or these Hollywood star types or the children of Hollywood stars. And they have, all they ever do is go out and party like crazy. And they never work. They never do anything. It's because their parents and their grandparents put money into these accounts. And exponentially, they make so much interest in a day that it's more than other people earn in a year. So the secret to being rich is to make money early, put it away, and leave it alone. Find a safe, productive, good account and just leave it there. Then you wake up years later. Now imagine if you did this, and then you go to retire and you have this much money. Now, this does not include all the money you made in between. Then when you die, you have a fortune to leave to your children.
Or you use it before you die.
Well, you're going to use some of it, but there's going to be so much. This is only the money that was the $2,500. Can you imagine the interest you earn once you get a real job? You're in the 10 to 20 million range, easy. Now, you take and you leave each of your children $1 million. One last calculation. Ready? You leave each of your children $1 million. And they get the money when they are 35 years old, you croak. They keep the money in there until they're 50 years old, 55 years old. So that's for 20 years, and they get the same 13.5% interest rate. What do you get as the amount of money in the account on $1 million, 20 years, 13.5% interest?
A lot of money.
Yeah. Now, do you think they could possibly spend all that money?
Yes.
I don't think so. So they in turn die and leave it to their grandchildren, and it gets bigger and bigger and bigger. Because you want to leave your kids some. You can buy multiple millions. All right. So, how many, hold it, moral to the story. How many of you guys are going to go home and say, Mom and Dad, you need to open up one of these accounts so that when you die, I'm a millionaire? How many people are going to do that? You're going to have a little conversation with your parents. Oh, the author, Huckleberry Finn, Tom Sawyer. He's brilliant. He had a, listen, he was a satirist. He always had satire. He had a great quote that said, when I was 18, man, was my dad dumb. When I turned 21, man, did he get smart.
Wait,
Think about
did
that.
you copy that last page in mine? It's not right at all. Not the chart.